Hello, guys. How are you guys doing? Good? Okay, I'm going to start with a story. Okay, do you guys want to hear a story? Yeah? Okay, let's hear a story. Three guys walk into a bar. Okay, have you heard something of the sort? Similar? No? I'm still going to change it a little bit because there are some very similar to this one. So let's say two guys and a girl walk into a bar. Okay, that's a little bit different. Okay, so the first guy comes into the bar with very well dressed. He has some glasses that make him look smart. His hair is all licked back, like it was licked by a cow. And the first guy goes immediately to the bartender and he asks to open a bar tab for his friends. Then the guy and the girl, they move to the bartender and they say, okay, the guy says, I want a beer. And the girl says, well, one as well for me. So each one, they start very simple with a pregame, a beer, very simple. At the corner of the bar, when they sit down, they notice that there's a homeless guy, just his trousers are all ripped apart. His t-shirt looks like he's 50 years old. And he's drinking water that he probably got for free at the bar. Okay. And meanwhile, they finish their drink. So the bartender goes to them and he says, okay, do you guys want anything else? And they said, okay, no, at least for now, I'm okay. But the bartender says, okay, but your friend earlier came in and he opened a bar tab for you. So you might as well ask anything else. And before he's even able to finish this sentence, they say, okay, then I'll have a margarita and I'll have a Moscow Mule, or maybe two because I'm thirsty and it's hot. So let's go with two. And this keeps going all throughout the night. They keep asking drinks, more drinks and drinks. Then there's a new round. Let's go with maybe some caipirinhas. Okay, let's bring them in. And about the fifth or sixth time that they call the bartender to the table, the bartender is, okay, maybe you guys should slow down a little bit. You guys have been drinking a lot. Maybe you should think a little bit more before you order the next drinks. There's even some drinks we haven't been able to finish yet. And they're like, okay, but maybe let's have some vodkas and whatever that is, maybe a martini, whatever. And just keeps going and going. And finally, they consider finishing the night. So they're like, maybe let's get a round of shots. Let's get some tequila shots. And at this point of the night, they're very good at math. So they're two. So let's maybe order eight or something, eight tequila shots for both of us. And they still look at the corner of the bar and it's still the homeless guy is still drinking the same cup of water. Okay, still hasn't moved. So they're like, maybe bring also a shot for that guy because he clearly looks like he needs it. And eventually someone needs to come in and pay the bill. So eventually the guy from the beginning with the suit, the glasses, he comes in because he needs to pay the bill, right? And he goes to the bartender, he asks for the bill. The bartender goes to grab the bill. And at this point, it's just like this roll of paper, which is like full of drinks. And the guy just cannot believe it. He's looking at it and the bill is $500,000. Okay, let's imagine $500,000. And usually when you pay your cloud bill, you're not drunk, right? But at this point, you probably sober up immediately if you looked at the value. And if you were drunk, maybe that was a good sign because you probably be misreading the value. So that would probably be a good thing. But you still need to pay the bill. And this guy, the business guy, he wants to understand, okay, what has the guy consumed? What has the girl consumed? Maybe I need to try to understand where can I allocate these drinks? Okay, maybe you drink two Moscow Mules, but they're wasted. They don't know. He asks them. They have no idea what each of them has consumed. But they do remember one thing. They do remember that they ordered a shot for the homeless guy in the corner. So the business guy trying to understand this, maybe he can even split the bill. He goes to the homeless guy. Maybe he's like, I don't know, a Silicon Valley founder or something. So he goes to them, bleeding face, and he's, can you maybe help me pay this bill since apparently we offered you a shot? And the homeless guy just stands up, still hasn't drank this shot, and he's, I left a couple of EC2 instances up during the weekend. I have nothing to pay with. I'm sorry. And then just finish his shot. So I hope you guys enjoy this little story, but let's go with who am I? So my name is Ricardo Magalhaes. I'm a senior DevOps engineer at Sinvertex Geeks. I've been, I guess, a DevOps for about 8 years. I started my career as a more on the front end, I guess, more front end full stack, working with React and React Native before actually transitioning to the fantastic DevOps world. And along my career, I never really messed a lot with FinOps and financial operations, right? But most recently in my project, the global economy, and especially the economy of the project that I've been working on is not so great. So I had to start thinking about these matters. And there were a couple of things that I had to start thinking about. And really understanding how early we were in the process of FinOps was really what prompted me to make this talk. So I do hope that you enjoyed that short story that I just told. I'm sure you understand it's just not a story about going to the bar and building a massive bar build. It's a little bit more than that. It's like an analogy of how companies try to manage costs when they don't have like processes and tools and some sort of culture of FinOps applied in their company. So it's a little bit of that analogy. And usually you end up feeling like this guy where you once again need to ask for their support. You don't want to feel like that. But speaking about this and going a little bit back, a lot of things changed when we start migrating things to the cloud. And when I speak about cloud migration, at that point in time when companies and teams start to think, okay, maybe it's very good and fruitful to us to move these workloads to the cloud, okay? And this changed a lot of things, right? Because first we solved a lot of issues, okay? So our systems became incredibly more scalable, more flexible. In terms of infrastructure, we solved a lot of issues, but in terms of complexity, it added some complexity because, especially in terms of FinOps, because there's some challenges in terms of managing money that really came from this, especially because we stopped paying we not only necessarily pay only for the machines that we have on premise now, and allocating costs based on the depreciation of those machines based or throughout the years. And now we're paying not only for that, but we're paying for things like not only for the machines, but for usage, for data transfer in and out. We're paying for storage space. We're paying for multiple SaaS. So all of that includes a certain cost, right? So we're scaling a lot our businesses. And as our system scaled, as you can imagine, the cloud bill is going to scale as well. You can say that if you scale around, you're going to end up paying out. Does anyone know this meme, the original one? I see a couple of nods, people of culture. Okay, very nice. For the ones that don't know it, it's not scale around the original one, but let's not focus on that. The same happened with the distributed systems approach, okay? So it solved a lot of issues. We fixed and solved monolithic bottlenecks. Our systems became more resilient. Teams became more independent, they gained more ownership. But there's also complexity added here because now a single API request is going to go from service A to service B, service C, and so on. And this single API request might even move through different regions. Okay, so there's a lot of complexity added here. And as you can imagine, this is very expensive. All of this data transfer in and out is going to be very expensive. And what we want here, or the goal of FinOps here, is going to help us figure out how to fix or solve all of this complexity, right? And in the vein of DevOps, this is not just a job for finance. We actually want to bring everyone in. So we want to bring financing, we want to bring engineering, we want to bring operations. Everyone needs to come up or needs to come together in order to make costs transparent, optimizable, and predictable in some sort of way. But we just talked about the cloud, being cloud native and the distributed systems approach. And when we talk about that, Kubernetes really is, I guess, a powerhouse when you talk about those two concepts. And no one does it better than Kubernetes. And it really is the backbone and the foundation of a lot of projects. So we can say that Kubernetes is a cost driving force. And I don't say this because Kubernetes itself is going to be the biggest chunk of the money by the end of the month, because it isn't. What you actually end up paying is the managed part of Kubernetes. So you don't have the hassle to, install the control plane, all the necessary software for the worker nodes. That's what you're paying with the managed service for Kubernetes. So that's not going to be the biggest chunk of your cloud bill by the end of the month. But you have, when we talk about Kubernetes, you have at least the underlying service, which when we talk about AWS is going to be the EC2 machines. If we talk about Azure, it's going to be Azure VMs. There's at least an underlying service that needs to feed your Kubernetes cluster. But then you need to expose your service to the outside world. So you need a load balancer or an API gateway. Maybe then you need a DNS service for your records. Maybe you need encryption, so you have some sort of encryption service. You need to manage secrets, so you need a secret provider. Maybe you're managing your infrastructure with also another provider. So all of these adds up to what you have on Kubernetes. So that's why I say that Kubernetes is a cost driving force. But I want to focus a little bit more on the underlying service, which is EC2 in case of AWS. And I want to do a little interaction with you, which is, I'm going to ask you a question, which is, Cast AI, the company, they do a study every year And they do a study about the average usage of CPU and memory across cloud providers. So the main cloud providers, so we're talking about AWS, Azure, and GCP. So my question to you is, what do you think the average CPU utilization was last year, so 2024, according to this company, to Cast AI? Do you guys want to have some? A lot of 30s. Okay. So if you, it was actually 10%. Okay, but 30 is a good option. But let's look into one of the pages of the report. So we can see that the average CPU utilization was 10%. Memory was around 23%. We can see that memory actually was marginally better from last year, but CPU actually went down. And if we look into the three values of CPU utilization, we have 10% for AWS, 12% for GCP, and Azure goes as low as 8%. So as you can see, we're crazy over provisioning our clusters. This is pretty much what we're dealing with on average CPU utilization. So 90% is actually unused. And then for actually running your workloads, we have 10%, only 10% of each worker. Each worker node is actually running your workloads. Can you spot the opportunity here? Do you have any idea what it means only using 10% of your workloads? Actually, it means that you could be mining Bitcoin with the rest, right? Why not? If it's 90% free, might as well use it for something. What? Do you have any idea, like in the span of 1 year, how much money you would make by mining Bitcoin with the free CPU? Because I actually did the calculations, and it's not great. It's not very good. It's actually very unprofitable. So I don't recommend you to do. It's not epic. Sorry, I have to make this. So this is not appropriate. It's not epic. And yeah, just don't do it overall. I'm not encouraging you to mine Bitcoin. I'm just saying you could mine Bitcoin, but don't do it. Okay, that's the difference. But let's look also into this. So imagining going into a bar where you're paying an entry fee for all 10 of your friends, but all 10 of you need to share a beer. Okay, this is a little bit what's happening with your nodes in your cluster. Every single node is getting a little bit of that beer, but you're still paying for every single one of those nodes. So it's a little bit like this. Okay, so let's do a very quick demo where I'm going to show you the difference that would be to run a 10 cluster node in terms of money, how much you would pay versus, and this 10 node cluster would be you over provisioning your cluster, and 3 node cluster would be the ideal cluster where you could run the same workload, but with less nodes. So let me see if I can quickly show you. So this is a very simple Terraform file that I have. It is really not necessary to understand what's here, but it's just we have the module of K8s, a VPC, and then the provider. Oh, sorry. Can I zoom this? Oh, okay. There we go. Okay. So this is very simply what we have here. And okay. So right now, this is what you would pay only for the configuration that we have currently. This is excluding any kind of usage. So this is just the base price you would pay. So you have $1,343 if you were running, a 10 node cluster like we're seeing here. And if we do a 3 node cluster, for example, so you would be paying around $478. So this would be the difference, which is a pretty big difference, as you can see. And this is only the base with excluding usage. Okay, so this would pretty much be the difference here between running a 10 node cluster versus a 3 node cluster. You would have a difference of $865 that you would actually be able to save and actually take this money and apply it to other areas of a project or another business unit that actually might need this money. So it's a lot of money. You could also do all of these things with it. It's up to you. You could buy 96 pastéis de Belém. Is anyone not from Portugal here? Hands up. Have you tried pastéis de Belém? Yes? You could buy 96 of them with this margin here. You'd be able to buy 0.0099 Bitcoin. This was yesterday. Today might be different. I don't know. And almost 5 SREday Lisbon tickets, which is pretty good. I think I made the calculations right, but this is pretty good. But let's actually get to the lessons itself. And the first lesson, it's very simple and it's abstract as well, but it's to actually explore the FinOps framework, which is available to all of us online. And this was what really prompted me to do this talk, was starting to read this and understanding that my project that's been running for so long is still so early in the process in terms of a culture of FinOps. So lesson number one is really to start looking into the base concepts of the FinOps framework. And within those concepts, we have a couple of ones. So we have the FinOps phases and we have the FinOps maturity level. The difference here is with the FinOps phases is what you actually are going to do iteratively while your project is running, okay? As your project, or while, I guess, when your project is still running is something that you're going to be able to do iteratively. You continue to do these actions. And the maturity level is how well you're going to perform these actions, okay? This is the difference between those two. Starting with the FinOps phases, we have three, okay? The first one, the inform phase, is all about feasibility. I think the most basic question that it tries to answer is how much money am I spending and where am I spending it, okay? It's about how much am I spending and the allocation of that money. So why is the inform phase important? Because we cannot optimize what we don't know about. So if we don't have visibility over where we're spending the money, we have no idea where we can optimize. The goal here is going to be to gain visibility into the costs, right? Where we're spending the money and how much we're spending. A couple of key activities here. So the inform phase is all about gathering information. So maybe you're working with a multi-provider. So maybe we have cloud bills to fetch from Azure and GCP, for example. Let's grab those. Maybe we have an outside database with MongoDB Atlas. Maybe you're using like a Terraform provider or an ISE provider of some sort. So let's get all of those bills from different places and actually aggregate them. Let's collect reports, curate them for different layers, product management, PM, POs, engineering team, and use those to actually send to the next phase to actually make informed decisions when we actually are going to optimize these situations. Then we can also create and fine-tune forecasts. So this is basically diminish the difference between what we estimated that we're going to pay by the end of the month versus what we're actually end up paying by the end of the month. And the goal here is actually to, okay, hello? Oh no. Okay, we're getting there. Let's go, buddy. Oh, yes. Okay, so the optimize phase is where we actually end up optimizing resources. It's all about where I can, not where I can cut some costs, those quick wins, knowing where we can cut important costs here. So why is this important? Because we're not going to be able to save what we don't optimize. I think that's a little bit obvious. And the goal here is going to be to reduce costs and maximize resource utilization. The key activities here, we're looking into tweaking resources in order to, like I said, avoid over provisioning or under provisioning if that's the case. Looking into using automation to maybe delete, maybe you have some idle resources in your cluster that you don't know about. Maybe you have some automation to automatically detect them. And after a certain number of days, maybe delete them. Leveraging cloud discounts, looking into things like spot instances, if you can use them, savings plans, all of those are important. And then finally, we move into the last phase, which is very important, which is what actually brings everything together and is how you get better in this process, which is the operate phase. Okay, and the operate phase is like the glue that brings everything together. I like to say is like the business needs meet financial goals and engineering goals as well. Okay, that's the glue that gets everything together. So why is it important? Because we cannot sustain what we don't operate. So it's important to keep revisiting our processes, making sure that we're using the best processes and tools as possible, making sure that we can streamline operations. The goal here is going to be to establish best FinOps practices and continuous cost management to maintain that optimized phase, that continuous improvement mentality here. A couple of key activities here, like this is the phase that gets everything together, streamlining processes as much as we can, put everything into day-to-day operations as much as we can, training your teams to not only understand the FinOps culture, but understand what they're gaining and what they're losing if they don't implement it. And this is also where you keep revisiting your governance policies, making sure that, okay, we need to custom idle resources. Maybe let's create an automation for this. This is where you revisit all those situations, and this is where you get better iteratively, okay? And then after that, we also have the FinOps maturity level, which is comprised of these three phases, which I think are very easy to memorize. Usually in the VAR context, most people do it the other way around. They run to the VAR, they walk to the counter, and then they crawl. Hey, wasted. You don't want to do that. It seems good, but it's not. But starting with the first one, the crawl phase, it's very much a reactive phase. Things are happening that you don't know about and you're reacting. Okay, so things are thrown into your path and you're reacting to them. This is why I say it's a reactive phase. It's a phase where not a lot of teams or very few teams in organization are applying those processes and those tools in terms of FinOps. Not a lot of teams already understand the benefits of the FinOps culture. So it's a very early on phase. It's not very evolved in terms of tooling and reporting. Those are very much limited as well. And this is the phase where you want to tackle those quick wins first, those things that you can fix very quickly that do not disturb your process too much. In terms of KPIs, to have just an idea, this is just some numbers. Other teams and organizations might decide or might think that other values are a little bit better. So you want to know at least where 50% of your costs are allocated and around 20% forecast variance. So that's the difference, like I mentioned earlier, of what you estimated that you were going to pay by the end of the month versus what you actually end up paying. So you want that difference to be as little as possible. Going to the next phase, the walk phase. The walk phase is not a react phase anymore. So you're not only reacting to things that are thrown in your way, but you're actually predicting them. You're actually being proactive about things. You know about those things, you need to optimize them. In this phase, you start to do a little bit about this. So now more teams are joining the process, are joining that culture and employing all those tools and processes. You have some manual work that's now being streamlined, is being included in that day-to-day, but it's still not in that perfect state. And there's also some difficult edge cases that you know about, but you're not necessarily tackling, okay? You don't have buffer to do so. The KPIs here are a little bit higher, as you can imagine. So we're looking about 80%, at least 80% of where your costs are allocated, and about 50% of forecast variance here. And then the most advanced phase of the maturity level, which is the run phase. The run phase is really where all your teams are bought into this process. All of them are using those tools and those processes. Those difficult edge cases that you were not necessarily tackling in the previous phase are now you have the buffer to start tackling those. And this is where those operations are really ingrained on your day-to-day operations. Everything is but everything is really streamlined within your day-to-day. Those KPIs here, now, once again, higher. So at least 90% of where you're spending, where your costs are allocated, and around 10% of forecast variance. Lesson number 2 is a very obvious one, but it's here because nobody does it. All of the lessons are pretty much obvious, but this is where I think most companies are still failing in terms of FinOps. But let's get to lessons. So lesson number 2 is to not over or under provision. Most teams tend to actually over provision to solve other issues or to prevent future issues like resource starvation. Well, let me over provision this if money is not a problem. They tend to over provision, but eventually money is always going to be a problem. So this is why it is important to mention this. Okay, is based on this short, this short cluster, do you think this is over provision based on these values? It looks like we still don't have idea if we're over provisioning in terms of resources or nodes, but this next one is going to help us a little bit. So if we take a look into the first one, for example, for pod number 1, we're requesting 1.5 CPUs, and the actual usage is around 300 millicores. So as you can see, we're very much over provisioning here. I'm just looking into that value, but if you look into the other ones, you can actually see that the same still applies. How can you fix this? There are a couple of tools that you can use. You have vertical autoscalers that's going to help you a little bit in terms of autoscaling your resources. You can look into other tools. For example, this is from Datadog. It's a print from Datadog that really presents you the first value. The blue one is the average CPU usage. Then you have CPU limits and then the CPU requests. So if you're not acquainted to these terms in terms of Kubernetes, so the limits is where your pods are capped off. So if it goes above the limit, the pod dies. Requests is the minimum guarantee that the pod gets, and then the usage is what you're actually using. And the best practice here is to actually get the requests closer to the average CPU usage. So if we're looking into the usage here, and if we say it's about 0.4, for example, we want to get the request not on one CPU, but maybe 0.5 or 0.6 is going to be the sweet spot for it. This is just an example coming from Datadog. Okay, lesson number 3, flexibility, but control. I say but control because flexibility can always have unwanted effects, because by the end of the month, the cluster can have some certain behaviors that is going to spike your cloud bill. So you need to be careful about that. That's why I say it needs to be controlled. And I've just mentioned the vertical autoscaling. We can look into configuring horizontal autoscaling in our cluster. These are the tools that we can work with in terms of, we can look into Carpenter or your native cloud provider autoscaler. That's going to work as well. Carpenter provides you a little more flexibility. The cluster autoscaler of your providers is a little bit more strict in terms of the machines you can scale. In terms of pods, you have the native horizontal pod autoscaler, or you have K8s autoscaler, which looks into things like message queues. It looks into things like database load, and it is actually able to autoscale based on those values. But these are just a couple of them. Before I actually say lesson number 4, I'm going to set it up with a short story, which are ephemeral environments. And very simply, this is what we did. So my team had the need to create ephemeral environments. So they wanted an isolated environment, which was composed of this application, which is the heart of it. And this application needed to be in complete isolation. They couldn't test what they wanted in development because there were multiple teams were developing at the same time. So they needed to completely isolate this environment for each of them. So what we did was we tightly coupled this to the pull request lifecycle, I guess. So the pull request was created. We created this ephemeral environment, which in terms of Kubernetes was pretty much just a namespace with all the components that this application needed to work. And once the pull request got deleted or either got merged or closed, then this environment would die. Okay, but there's a problem here. The problem here is not about the pods. The problem here is about the volumes. And with this setup that I just did, you want to try to guess what the problem was? Any ideas? Sorry? The size of the volumes. Yeah, you might be onto something. So this image is going to help. And I purposefully made it like this for you to understand. So this is a bunch of volumes just hanging in the cluster. So what was happening here? So once the preview environment was deleted, the namespace was deleted as well. But here's the problem. Let's zoom in a little bit. Look at the reclaim policy. So every single volume has a reclaim policy of retain, which means that even when the namespace was deleted, even when the pull request was closed, the volumes were still hanging in the cluster, which means all of those, that ginormous list was still there. And obviously we're paying for every single volume that we had in our cluster. So this was a big issue in our case. So lesson number 4 is really unused resources are literally going to make you pay. The next story, not next story, but lesson I'm also going to set up, which I call hidden resources, because hidden resources are going to hurt you as well. And this is how the story went. So this is the story of me looking into the cost explorer of AWS. So I'm looking into it and I have Route 53, the DNS service, very important service. I'm paying almost $2,000 for it, but it's very justifiable. Okay. Relational database service, also very fundamental. So very okay with it. Then we have tax. I know what tax is. Our highways are going to get better next year, I'm sure. So very cool. Then we have elastic load balancing, very important. EC2 instances, $10,000, very much justifiable. But here's the problem. Look into this one. We have EC2 other, and I'm looking into this. I'm like, other what? What am I paying other? When I'm going to my boss and he's, what am I paying $26,000 for? And I'm like, EC2 other. And he's me, other what? And when I see something like this, my wheel is like, can I pay with Monopoly bills? It's some other money, right? This is my wheel here. So my point here is, even if you think that you're safe by using cloud providers, like you have all of the costs very much extrapolated, think again, because you have entries like this, you have EC2 other, and if you don't have like a tagging resource in place, tagging convention in place, you will not find out that EC2 other is everything that is not necessarily related to machine learning, things like elastic IPs, net gateways, data transfer both in and out. If you don't have your tagging convention in place, you're not going to be able to find out this. Okay, so that's to set up the lesson that enforcing tag on all resources is very much important. In terms of tagging strategy, you need to know what tags to use, and in here you need to be as specific as possible. You start from the top down, you start tagging environments, you start tagging teams, you start tagging business units, everything that you can tag, put a tag there, be very specific. That's the goal here, be very specific, because when you're going to filter on the cost export to understand what EC2 other is, you need to know exactly where it comes from, and this is where tags are going to help you here. You can enforce this tagging on CI/CD, on Terraform, etc. And maybe I can quickly show you a tool that you can use very quickly. So to do that, I'm going to uncomment this piece of code here. That's going to be necessary. Okay. For example, you can very simply include this tool, which is called tflint, which pretty much you're going to define a very simple rule. For example, this one, which is the resource missing tags, and you're going to say the tags that you need to be enforced on this resource. And if any of them or several are missing, it's going to warn you about this. So in this case, is clearly warning us that cost center, owner, project, service team, etc., are not enforcing this in this resource. So this is something that you can very easily set up in your CI/CD pipelines. You can also use AWS config, for instance, which tracks post-deployment compliance. This is actually going to look into your resources that are already deployed and is going to warn you about things. For example, if we take the tagging example, if there's a resource running that does not have the necessary tags for you to be compliant with your governance policies, then AWS config is going to warn you about it. Lesson number 6 is going to be to include FinOps in software development lifecycle as much as possible. So in here, we want to look at things like incorporating financial risk assessment as early as we can in the process. So knowing where we might have some unwanted costs by the end of the month, try to predict that. So include that as early as you can in your software development lifecycle. Enforce this resource tagging on the CI/CD as much as possible. And I just show you a very simple example that you can very simply put in your CI/CD pipelines. Use budget thresholds like quality gates. What I mean here is once you start working with budgets, you have a defined budget, maybe use it for, like it was the SonarQube quality gate, for example, is where you say that if you go above this budget, if the estimate cost is going above this budget, then we break the pipeline here. We cannot go forward with this deployment. That's what I say with using budget thresholds like quality gates. And then the final lesson, which is a very short story also, it's a trust but verify. So you have your cost explorer, you're looking into your AWS costs, you see what you're paying for RDS. And this is something that happened with me. I was looking into RDS, we're paying a big value, but for me, it was very justifiable to look into RDS and seeing that value. But then I click on the expand button and that drop down came, that drop down appeared. And then I'm looking an entry which was the extended support for RDS, which pretty much the extended support is AWS guaranteeing support for you running, for example, your Postgres engine in a deprecated, not a deprecated, but a very outdated version. Okay, they say that they're going to provide support if you pay a buttload of money. Basically, that's what's happening. So just by upgrading Postgres in this very simple example, we were able to save, I think it was around 60-65% of what we were paying for RDS, which is pretty significant. So lesson number 7, and the final lesson, which is actually double down on visibility, because that's one of the most important, if not the most important concept in terms of FinOps, and starting with FinOps is knowing where you're spending your money and how much you're spending. That's very important. So by the end of the night, when you're going to the bar, you don't want to be that guy. You don't want to be the homeless guy in the corner that lost everything because he left a couple of EC2 instances on. Just try to read a little bit more about FinOps, like I started doing it, and it actually prompted me to make this talk, learn a little bit more about it. I actually consider it to be still very early on in my process in terms of FinOps, in terms of the FinOps path, but I hope you guys enjoy the talk. If you have any questions, thank you so much.